Okay, I think it's time to start. So first of all, welcome everybody in this session from the Biodiversity Data Interest Group. I see that we have 22 participants already currently in the session. So this is quite good actually. Can you present the next slide, Libby? Yeah. So first of all, we have to celebrate something because our charter was just endorsed by the TAP and the Council. So that's very good news. So now we have a new charter for the interest group, and we are again endorsed as an RDA interest group. Also, thanks for the TEDWIC Biodiversity Information Standards for their financial support to some of the speakers in this meeting. And one other announcement I would like to make, maybe you have seen it already, but we have now also a discipline-specific page for biodiversity in RDA, in the RDA website, so that it will be easier for people interested in biodiversity data and the activities in RDA to find what's going on. The notes for the session, for that we have a Google document. Libby just shared the link to that document, and I would like to invite you all to put your name in that document together with your interest in the topics in this group. And I will now give the floor to Libby, who will share the rest of the session.
Thanks, Wouter. Yeah, so just a quick introduction to some of what the group has been up to recently. In response to many recent developments in the biodiversity sciences and to align with developments in other scientific domains, the interest group charter was updated. And as Wouter just mentioned, this was recently accepted. And this was accomplished over the course of the last 9 months or so, and involved several different periods of discussions, open periods of commenting, and several revisions. And so I just want to highlight a few of the main points that are now included in the charter. First, the objectives here. The group aims to steer discussion and to coordinate efforts that create synergies among infrastructure developments around biodiversity data, and to connect these with RDA developments in the wider interdisciplinary research infrastructure landscape. Infrastructures cannot operate in isolation, but need to be part of the same value chain to deliver scientific outputs. So this overall aim can be divided into these 3 main objectives here: to impact, influence, and disseminate some of the wider RDA strands, crossbreed biodiversity standards and solutions with other domains, and to create recommendations and guidelines for specific biodiversity data integration issues. The use cases the interest group wants to address have changed over time, of course, and this triggered an update as another thing that triggered the update for this charter. And so these areas were recently identified by the interest group members as possible scenarios and use cases. I won't go through all of them. And some of these will actually be touched on by some of the speakers later on in this session. But just to highlight a little bit of it, data integration for biodiversity data, to increase usage of research data by biodiversity authorities, policies for referencing data, biodiversity data and essential biodiversity variables, developing guidelines and promoting synergies between existing initiatives. So that's just kind of a quick overview of the charter. The full charter is online on our the webpage, our RDA webpage, if you wanted to take a full look at that. So that's available. And these are the current chairs of the committee. It's myself and Wouter, Sridhar Gautam, and Hamish Alewa. And today we're going to be hearing from Jerry Lanfear, Donata Gasti, and Yvonne Lebras, and Alex Hardesty. And there'll be time at the end for some wrap up and further actions, discussion around that. And as Wouter mentioned at the start, there's a Google Doc, and we'll continually put that in the chat so that if anybody comes or goes, we can make sure everybody's in there. So please feel free to put your name and relevant information in that document. And without further ado, I'll stop sharing here and pass it on to Jerry. Jerry, are you able to share your screen?
Is Jerry with us? He might not be here at the moment.
I know Donat's ready to go. If we need to come back to Jerry, we certainly can. I don't see Jerry. Okay. Should we just skip ahead then and come back if need be? Or if he joins us? Donat, are you all right with that? All right.
So you want me to
You're on.
start? Okay.
Thank you.
Hold on. Okay, so thank you for giving us a chance to talk to you about this State of Disco COVID task force, and specifically about the aspects of publishing biotic interactions. So as you see already here, it's a loaded group. It's not just a few people, there are many people involved. So even more. And the reason we started to work together was last March, when it became obvious that there is a problem about a virus spill from an animal to man called COVID-19. And it was actually interesting because we thought, well, we liberate data and make data accessible so we can actually contribute towards understanding and resolving, and also in the future getting a better handle on viral spillover. But the really interesting thing was the experience in itself. So Nancy Simmons, one of the, the big bat experts in the world, working at one of the most famous natural history museums in the world in New York, got into confinement. And her problem was that all her books and PDFs and everything was closed up in the office. So it was not just a problem that she did not have access to quite a few publications because they're closed access, but also that she not even had access to her own publications. So the problem we had then was to get missing data on biotic interactions between the COVID-19 and the host bat. So these are interactions. We needed to know more about biodiversity and biogeography of bats, the taxonomic names, which is an important thing to actually get data. We wanted to know more about biology and behavior of bats, like co-roosting and predation. Then there was the issue I already mentioned, that's access to data, to physical, like the books. And ironically, the most important book in the bat world, the Handbooks of the Mammal of the World, has been published in 2019. It was only accessible in book form, so there's not even a digital copy of it. And it was a coffee table books size, so it was difficult to buy for most of the persons in the world. Then a lot of the data is in silos, so everybody has its own database and reference taxonomies. Then once you have these references, they are not linked to the sources, so you need to find out what means essentially this abbreviated citation, and then once you have that, you have to go find it somewhere. And then that's the old issue about open access to digital data and publication. In taxonomy, it's bad because maybe 80–90% of all taxonomic publications are sort of closed off. So in a nutshell, what we achieved, a very big thing was that we created custom metadata on Zenodo, so we could make the Zenodo repository very specific to for our purpose. I will explain this in a minute. Then we created a workflow data extraction from publications to make it fair data to reuse by Globi and by GBIF as examples. And then we got new tools for publishers to publish machine-readable interaction data. So that's essentially, you can look at the data we liberated. You can find this all on the slide, which you can access through the DOI. So essentially, we created two workflows. One is both started by finding publications, then data mine publications. In the one case, name it for named entities, then annotate the publication and make it so it can be reused. The second one is to find publications, data mine again, find named entities, find named entities, and then create out of sections of the text and images fair data and make it reusable. So essentially, when you look at the first workflow, we worked with the Swiss Institute of Bioinformatics and their library service, and who created a COVOC, coronavirus vocabulary, which is used for text and data mining. So it's essentially vocabulary which includes many vocabularies from anything related to COVID, including also taxonomic names of hosts and viruses. Then we did data mine, which was, once we had the publication, we did data mine, and then we did annotate these publications. That's typically a human who has to go through the publication and say, actually, this is the interaction with this, which is very tedious. And we applied ontopy as the ontology. Then we uploaded this on Zenodo, created a coronavirus host community, and then Globi came in and reused data. So essentially, when you look at this a bit more in detail, so we got an article, we used the ontology terms to annotate, then we created custom metadata like this custom metadata now on Zenodo. So essentially, it shows you the interactions between this, and it says what it does, so it's host of. Then Globi is reusing it. That means we created essentially from a publication a deposit of the article in Zenodo, and we are not primarily interested in opening up the article. Of course, it would be open, but we're interested in this side of it to make actually the data which is relevant for us accessible, and accessible for us, not just to read, but also for machine readability. And of course, link this to respective ontologies, like in this case, this one on the OBO ontology on biotic interactions. And another important element was that through Globi, we actually got feedback. So if there's a link wrong, you can make a statement it's wrong, and it can correct that. So that's an important thing, that we have workflows which have quality control and feedback mechanism inside. The second workflow is one Platzi kind of championed, is that we essentially take data, we take figures and treatments out, we annotate this. Again, we use Darwin Core to annotate the treatment data, and then it's also reused, in this case by GBIF as an example. So what we did, we bought the book, so I'm owning this book, I cut it in pieces, we scanned it, we converted that, and we uploaded then the book to Zenodo, but we make a lot of annotations. So again, we had a lot of metadata, and the metadata essentially is interesting because it links to the treatments we extracted and also uploaded to Zenodo. So we created on Zenodo a taxonomic treatment element, which is a data science text sub-element, which is like all the data. So it's the description here. It has it in an XML format, but again, it has a lot of metadata. And it has custom metadata, like in this case, there's a custom metadata which refers to TEDx, Darwin Core, which shows the geographic data. And that's special because normally metadata can only be one term, but in this case, it's a relationship of two terms like geographic coordinates. So we customized again Zenodo to a degree which is important for us or our community. And the same we did for figures. So essentially we took figures out, we extract them. And of course, there's a lot of metadata so you can find it. So in the GBIF case, we extracted this data from this publication. GBIF takes this publication and in this case, it's a chapter of this handbook. It takes all the occurrences out. It can, as one of the applications, it throws maps. And so you have a point, and the map points back to the taxonomic treatments which we have on Zenodo. And in this case, GBIF also is reusing this data, creating their own view of this data, including the figures. But we can also annotate, like in this case, barcodes. So we can by machine find these barcodes, and we can update them with the link to the BOLD system. And that's a dream of us, that we essentially can take this data and make it really linkable. And that's, again, it's important for us, so the reader can click, but more importantly is to create knowledge graphs. And the really important point is that it's not just that we have a workflow now from PDF to treatment bank to GBIF, but the same data we have here is used by many other applications. It's even used via GBIF by Bionomina, because it's all now standard vocabulary use. They can use it. It's now being used in the genomics world. So the treatments are going out there, and they're used as for text and data mining, and hopefully become an element in PubMed Central. The Wikidata has now a chance to link a taxonomic name back to the scientific data. And also importantly, Google now has a much better chance to find your data because it's really exposed. And again, here, an important element is that there's a lot of quality control now. So we have quality control within our own system, but it's also their feedback mechanisms. So if GBIF discovers an error, they can send us a feedback note, and we can fix it. And we can fix it very quickly because it's a live link essentially. So all the programs we use are open source. All the data are open and fair. The liberated data is quality controlled. I think it's very important. The data, and as well as the code, is version controlled, and all the processes are continuously automated, creating a steady flow of index and scientific data. That means if you process something, it shows up in Globi, it shows up in GBIF, and it's essentially for everyone. So the lessons are, which I think we really need to do, is say we can liberate old data, so we have means and tools to do that, but it's not the best way. But we have also new data publishing tools now that can make sure that all this tedious workflow can be cut short. And we really need to go out and talk to people about this. The liberation itself is very expensive. It's hilariously expensive if you start thinking about this. It's technically very complicated. It's also error prone. So there are a lot of errors from the beginning to conversion to there's many things, but we can exclude a lot of the errors. And if we don't have the resources to scale up, even if you have bicycle, it's only drop in the ocean. So essentially, again, we must think also in this group that we think really how we can create linked data. How can we create data that is open knowledge? Another lesson was that we had a question and we wanted to work towards that. So everybody contributed in many ways. So by buying books, which we could not get otherwise, and chopping them off, to make changes in Zenodo and so on. So it's a good lesson that if you actually rethink the way we do science, mainly one by one or in small groups, we can do much more. So I think there's a lot to say about open science. And so essentially, one of the really important conclusions is that we should stop wasting time by publishing and making data accessible the way we do. We cannot afford to do this anymore. So that's in a way also our main conclusion and statement to the world. So with that, if you have any questions, feel free.
Wouter, it looks like maybe you're muted. Thank you, Donette. Yeah, Wouter, were you saying something better?
So there's a question in the chat. And the question is, what is the alternative?
The alternative is very simple. Make what Pensoft does, or make it better than Pensoft. So your challenge is to get your data into Globi. Your challenge is to get all your taxonomic or biodiversity data into GBIF. If it's there, you do it right. And the way you do it is open. Hopefully there are many clever people and people around that can find solutions to that. But the important thing is that we don't have to go back and start again and extract data.
Okay, any other questions? You can ask your questions in the chat, or you can raise your hand to the hand raise function. Okay, I don't see any other questions at the moment. So I think we can continue, Libby.
Yeah, let's continue. I was just looking for Larry in the participants. I don't see him, so let's just continue. Yeah.
Come è facile intendere in...
Well, I think that was not for the session.
Ivan, if you're ready, Ivan Labras.
Yes, I can try something. I try to share my cam. Hi, everyone. And I can try to share my screen also. That's it. Okay. Whoop. So good afternoon, everyone. So first of all, I will try to speak quite clearly, but my English is quite really poor. Sorry for that. And moreover, I just have a new son who come last week, so I'm quite yeah. I try to do my best. So I will try to do my best to be understandable. And first of all, to share my screen. I think I will share my over my screen. Okay. So like this, did you see the presentation? Super. Thank you, Libby. So I'm Yvan Lebras from the French National Museum of Natural History. Here I show two places where I work because I work in Paris, this beautiful site from the Jardin des Plantes. If you have the chance to come to Paris, you can visit it. It's a beautiful place. And also I'm working in a marine station in Concarneau in western part of France. For sure you didn't know, but if you have the possibility to come to Concarneau, please come and see this beautiful marine station, who is the oldest marine station in activity in the world, apparently. So here there is some name of people, member of the Biodiversity implementation networks. So the presentation is shared. I put the link on the notes, so don't hesitate to take it and ask questions if you need. So we speak about biodiversity. I hope my slide will, yes. And GoFair. So I'm not sure you are aware about GoFair. So I will speak a little bit about GoFair, who was meaning for Global Open Fair, and speak also about another concept with IFDS, so Internet of Fair Data and Services. Quite rapidly, but just to give you a little bit of context. GoFair is a bottom-up, stakeholder-driven and self-governed initiative. That's something quite important in our point of view, because this is a place where when we are not in international infrastructure or big initiative, we can propose something. We can propose an implementation network, and we can have the possibility to go on and work on these things, even if we are really small. So that's why I was using go fair. And I think there is some initiative like this where we have small initiative who can ask to begin to work into an implementation network in GoFair. So GoFair, it's huge things, huge initiative that aims to implement the fair data principle. The idea is to work communities by communities. This can be big communities or really small communities. And GoFair is working on 3 different pillars, who are Go Change, Go Train, and Go Build. So Go Change is more related to cultural changes, in fact. Go Train is devoted to training activities. And Go Build, who is the place where we can have where there is the more important number of implementation network and work, is really more devoted to technology, in fact, standards, tools, platform, and things like that. And that's where Biodiversity is. And GoFair is really speaking about this concept of Internet of fair data and services, who can be showed or demonstrate, speaking about an hourglass picture and the success of Internet. In fact, if we think about the success of Internet, we can think about a lot of things who made Internet successful. But one important thing, maybe the major point, is technical, but not only technical, is that through Internet, you have a lot of different initiatives over the world where people meet the fact that they want and they are agreed to use a limited number of standards. HTTP, for example, or FTP, or other protocols or standards. And if we think about that, in fact, there is not a lot of initiative where we see that we have such an agreement of research, academic, industry, citizens, part or industry, who are all agree to use the same standard. So I think it's quite interesting to start with this idea, because in GoFair they were speaking about that to present a little bit of the idea. So the idea is to work on standards and on this hourglass orientation. So using a minimum core of standards, have we got some possibilities to give access to an infinity of services and related to an infinity of data? So how we can link infinity of data, services, and users, in fact, through a minimum number of standards. And that's really interesting approach, I think. So now I will just quite rapidly, sorry, the slides are not the best, but some screenshot of the work program of Biodiversity, just to show you a little bit of the content. So in Biodiversity, we are working for biodiversity communities. And the idea was around the fact that in Biodiversity, we have a lot of standards, we can say, but not so much. In fact, I was working 10 years for bioinformatics, and it's really more the mess in bioinformatics when we are speaking about standards and how we can try to agglomerate or to work with different standards in the same times. In Biodiversity, it's not the case. There is not so much standards, and there is one particularly interesting standard with ecological metadata language, EML. So I am an EML lover, so we can discuss about that, and I hope we can discuss about that and challenge that, because it's something quite important for the project too. So in the project, the idea was to work on different subjects, technical subjects like standards and mapping. So try to work on different standards, look at the mapping between the standards, and propose tools to convert from one standard to another. And after that, to address fairization challenge regarding standards and mapping. And the same for data and metadata portals, for example, looking at existing portals and what can be the manner to address fairization challenges regarding existing data and metadata portals. We make the same for another big part of the project, which is related to a web platform to analyze data, where in fact, thanks to this GoFair work, we created a Galaxy for Ecology initiative, who is related to the fact we use Galaxy with a platform used in bioinformatics, but trying this concept coming from bioinformatics for biodiversity. And it was quite interesting to see that it's really something we can use, who is really interesting to use. And we can go really deeper on that, working on, for example, EBV, so essential biodiversity variables. And for GeoBon, for example, in France, we propose an EBV operationalization pilot who is totally linked to this work on Galaxy. Another part of the project is related to dissemination and communication, and in fact around training and how we can help training people on the way to be to address fairness issues regarding data, metadata, tools, and other things in biodiversity. And here we work with several initiatives like e-learning platform used by JBIF, for example, and also working on initiative related to carpentries, if you know data software carpentries, and notably using it on Galaxy, because now we can reuse carpentry infrastructure to propose e-learning material for Galaxy user, and using Galaxy platform to give access to tools, workflow, and knowledge, in fact. And we also try to work on small-scale initiative. Here we don't go really deeper. I hope we can do so in a more deeper way in the next future, but notably working on collaborative work, crowdsourcing work around, for example, creating links between biodiversity data, expert, and citizens. So we try to make something around notably the taxonomic identification, but also about other information related to, for example, adding metadata information on existing data or things like that. We can also speak about that. There is a lot to do and to speak, I think. And a final part of the implementation network was devoted to address future challenge, try to see if there is related things we can try to use to accelerate the fairness of our products, in fact. And for this, there is notably two sub-projects. One is related to the creation of data management plan automatically from metadata, for example, to promote the fact that we can have machine actionable management if we have a strong metadata standard we can use to have a lot of information on different research objects, but also on infrastructures. And the other part is related to the fact that there is an issue, particularly in biodiversity, to have access to open data and to raw data who can be in open access. And one way to go really rapidly in this direction can be the use of decentralized infrastructure, in fact, maybe using technology like blockchain and peer-to-peer is something we can maybe use to promote the fact that we can directly share a lot of data and giving value on each value and having provenance of the transaction between data. This is something really interesting. We don't go deeper in this direction, but we make some tests, and we are happy to exchange and try things if you want to comment this. So just quite rapidly, the idea here is we try to create a biodiverse hourglass view where we take some standards and try to make link between services and data, looking at centralizing it on standards. So here I put a particular emphasis on EML2 because I think there is a lot to do on that. And that's it, I think, for here. So there is a data point of view and computing, scientific computing point of view, HPC point of view, and we can discuss about that also. And the final things maybe is to speak a little bit about what we are working now in GoFair with the fair implementation profile, with, I think, a really interesting manner to capture the community needs, with really something important, I think, even if the community is large or really small. And this fair implementation profile ID is really related to the fact we can ask, like using a questionnaire, for example, and using FAIR statement, ask people to evaluate their community and their information systems regarding FAIR principle, and try to have different answer by community or information systems, and create a matrix like we can see there, and work on a matrix to help new community to maybe reuse existing FIP, or try to promote the I can say that the convergence of FIP. I think this is something really interesting we can do at any scale. So if I speak about that, is also because I have the chance to propose you to come at the next meeting for a CoData GoFair International Fair Convergence Symposium, where we will animate a workshop named Towards Fair Biodiversity Virtual Research Environments. This can be quite disconnected, but in fact, the idea is really to go from what I present here, from the standard point of view, fair implementation profile point of view, and go towards machine actionable things who can be used to create virtual research environment on demand or things like that, at least a template maybe. So if you are interested by this subject, please come at this event, the 1st of December. And yeah, I just give some pointer here on this workshop, because the idea is trying to work on this the 3-point framework for verification proposed by GoFair, where we can work both on metadata and metadata for machine aspect, fair implementation profile, looking at choices that communities made, and link this with fair data point, to work on this idea about maybe EML, for example, is a super standard we can use. This is my hope. I hope this is true, but at least we can try to go deeper on that. And through this kind of idea, connect this to the research life cycle, and so propose virtual research environment. We can connect, we can create from research object. In fact, we can mobilize through metadata. This is quite raw information and thinking there, but if you think the subjects are of interest for you, please come at this session and we can go deeper. And I think it's quite finished. Yeah, it's just this research object point of view is for me quite central. It's something we can address quite magnificently, I think, notably with EML, for example, because this is not just metadata for data. This is also for protocols, methods. This is also for software, and we can track provenance also information thanks to EML or EML framework. And one important thing I think is the projection. When we have a matrix like the fair implementation profile matrix, in fact, depending on the projection we make on this, we can have different point of view, technological point of view or user point of view, and this can be something really useful, I think, for all e-infrastructure related services and products. So yeah, I think this will be a beautiful things to discuss about. And the last, I think, the last part of the talk is here some try we made with EML, and notably we are really happy that a French project is now accepted, so I can work fully on EML to try to expose the potential of these standards, plenty full potential of this standard to work on creation of DMP or data papers. We can maybe try to propose to high-level publisher for high-level high impact factor review, for example, or things like that. So a work we can start next year with Giga Science review, notably. And I think that's it. Yeah, just a point of view on standard, but yeah, that's it. Thank you, everyone. I hope I was not too long. If you have questions, comments, please don't hesitate.
Thank you, Ivan. If people from other parts of the world would like to follow your approach for their own use cases, what would be the best way for them to do that?
You mean to propose or?
Yeah.
Yeah, the best can be to join the Biodiversity implementation network. Please, it's open and you can join at least to propose things or comment things. Yes, coming to this next meeting or sending emails yeah, I think this implementation network is the best place to start such work on different use cases. And for example, I know in this interesting group, you are working maybe more on collection, something I am less oriented, in fact, in my work. And there is really crucial questions related to connection with collections, museum collections. So I think definitely this kind of things can be a big addition and big interest. Yeah.
Okay. What are for you the most important work that is being done in RDA? Are there some particular RDA outputs that are of interest for your implementation network?
Maybe it's I don't remember the name, but it's the DMP common common standard, or there is a working group in the RDA working on DMP, and they create standards of terms we need, information we need to have into DMP, and this is things really we can use, in fact, in an operational way to try to, for example, make a mapping between EML and this DMP common language standard to create DMP or things like that. Or you are speaking maybe about this RDA interest group?
No, RDA in general.
Yeah, because I'm really sorry, because I was quite not participating a lot to RDA group, and in particular this one, BDI, because often there is discussion maybe here, but for example, more related to collection, where I really know less, orientation where I'm not really knowing a lot. And in other RDA working group, things like that, often the discussion are not enough directly linked to an issue I encounter for my communities. It's maybe too general or things like that. That's why also this BDI interest group is for me of prime interest, because this is focusing on biodiversity, and this is a place where we can discuss about questions we have in our communities, even if I really agree that discussing about big shape and more general thing is really crucial, but I have not a lot of things to give in this direction.
Okay. And there is a question in the chat from George. You mentioned blockchain and decentralized infrastructures to help make data accessible. Can you elaborate on this? Specifically, how do you see existing centralized infrastructures would contribute to this?
Very good question. In fact, and I know that there is some work in progress in LifeWatch on that. I was aware about that just a few months ago and discussed a little bit about that, but it's really interesting because for me, it's something quite, for example, for centralized infrastructure, this is something quite dangerous to see that there is a manner to have decentralized vision or decentralized infrastructure. So there is some kind of danger here, and we can think that this can be an issue potentially for the actual systems. But if we want to propose to, I don't know, all the biodiversity researcher in the world to share their data in 2 clicks tomorrow, it appears to me that the only way to successfully address this challenge is to use this kind of technology. And thinking about it, I am thinking that additionally, we can also give value to data, because we always say that data is the goal of a lot of things, business notably. But in fact, what is the cost of a data set? We don't have a lot of information about that. Using such a kind of technology, we can have an idea about the fact that even if it's a little and maybe old data set, this data set can have a really big value, because some people are ready to give a lot of money in such a data set. So this is something interesting. And the last thing is the idea of traceability, because this is something quite complicated to have. Even if we have beautiful centralized infrastructure, we can track provenance. But using such a technology, we directly have this traceability, and we can also accept to have centralized infrastructure who can be connected to this kind of decentralized infrastructure, and maybe with a particular role, but not the decisive and final role. And this is something quite interesting. I don't know if it's really usable like this, but I think there is something interesting on this idea.
Okay. So another question from Donat. How would the data in the library of the Museum National d'Histoire Naturelle look in blockchain like?
Very good question. Yeah. Really, I really want to see. I really want to test it, and there is a lot of questions related to library and that and collection, real collection, and I really want to test things and see how this can be of interest or not. Yeah.
Okay.
Yeah, and Roma, I see Roma speak about the fact that blockchain is also considered as a veracity improvement tool in Earth data. That's true that in bioinformatics, for example, there is beautiful example of such. Maybe blockchain is really a good, but combining blockchain and peer-to-peer technologies, really, if you can look at example using it, it's really interesting, really.
Okay, I see no more questions. So, Libby, I think we can move to the next.
Yes, and still no Jerry, so I guess we'll go right to you, Alex. Hard to see.
Hello, I'm Alex. Good afternoon, good morning, good evening, wherever you are. Okay, do you see my screen?
Yes.
Okay, good. So on the agenda, this item is described as goals and plans for a new joint working group on open digital specimens under this RDA interest group, and jointly with TADWIG, which is the Biodiversity Information Standards community or grouping. My name's Alex Hardesty from Cardiff University in the UK. I'm working in the preparatory phase project for the European Research Infrastructure Distributed System of Scientific Collections, which aims to bring together all of the collections in Europe in a unified research infrastructure to support new working practices. And within that work, I'm leading on an initiative to develop specifications for what we call open digital specimens. So the context for this agenda item, and I picked this up from the revised charter. At a high level, this is concerned with discussing and developing recommendations and guidance to bring about digital transformation within the biodiversity data domain, influencing the use and dissemination of existing RDA standards into this biodiversity domain, and identifying new recommendations and guidance that the domain needs to achieve further integration. And if you remember the scenarios that Libby listed at the beginning when she was talking about the charter, this is the one that is concerned with data integration through natural science collections, creating recommendations that link data together using the hard evidence or based upon the hard evidence of physical specimens. And so in development, outside of this outside of this interest group, we have things like the open digital specimen specification, the standard on minimum information about digital specimen. We're talking and thinking about how to identify digital specimens using natural science identifiers, and it takes into account the digital specimen and extended specimen concepts, which I'll tell you about in a moment or two. And so the charter gives us the permission in this interest group to use the interest group to discuss and enhance these elements as part of the wider Research Data Alliance landscape. So digital specimens. Here's a very quick introduction or summary. I think many of us are familiar with the idea that there are billions of physical objects locked up in collections in museums and research institutes around the world. Estimates are somewhere close to 3 billion physical objects in collections relating to biodiversity and geodiversity. And these things are used in research, many different kinds of research, to understand the diversity of the planet. And often the data that's locked up in those physical specimens is released through digitization, through analytical and computational methods. And indeed, we've heard very clearly from Donat earlier about how data relating to physical objects that are involved in the transmission of coronaviruses and COVID has been released in various ways during the course of this year. And we aim that all these different kinds of data, genomic data, biochemical data, morphological data, geographical data, taxonomic information, species interactions data, ecological data, and more, can be aggregated into actionable knowledge units on the internet that allow them to be further processed using data science techniques and computer assistance. These digital specimens act as more than digital representations. they act as processable twins on the internet for physical specimens in collections. And importantly, they can be manipulated, they can worked on, actioned remotely across a network by machines and by humans. And of course, we tend to forget about and understate this aspect of processing by machines, because most of us are familiar with the traditional way that humans work with specimens, which doesn't often involve machine processing until relatively recently. So this is the concept of a digital specimen as a fair digital object representing a physical object in a collection. And in the USA, a similar concept has emerged in the same kind of timescales. There, it's called an extended specimen. And here you can see it illustrated on the left, again extending out from a physical specimen with close to the physical specimen, a digital specimen record and images and other stuff related to the physical specimen. And then as you move into the secondary extensions and the tertiary extensions, bringing in links to other kinds of derived data from physical specimens, and allowing that to be easily found, easily used, and manipulated. And there's an article about that was published in Biosciences earlier this year, and there's just a few examples there from the New York Botanical Garden and the Kansas University Biodiversity Institute and the National Ecological Observation Network, the NEON Plant Monitoring Program, that show some ideas about how that is being put into practice. I think it's important in the context of this interest group to recognize that the digital specimen concept is really emerging as a result of the work that particularly that we've done in Europe, trying to understand which of the Research Data Alliance recommendations and the FAIR guiding principles are necessary to support the planning and implementation of the DISCO infrastructure, particularly considering that that infrastructure has to work in the bigger landscape of the European Open Science Cloud, which is a high political priority of the European Union over the coming years. And so we have this notion of digital specimens being a kind of digital object which sit in the digital object architecture, referenced by some kind of persistent identifier, described by net metadata, and deposited in repositories such that they can be found and processed. And this is all of this work in the Research Data Alliance, particularly and strongly in the Data Fabric interest group, but not only there, is shaping a federated data fabric, which you heard Ivan talk about a little bit in his presentation. It's coming with the name of the Internet of Fair Data and Services, where fair digital objects sit in a framework that allows multidisciplinary science to be conducted more expansively in the future. And so this agenda item was about suggesting a new joint working group between this interest group and TADWIG to work on a specification for open digital specimens. But since we proposed the agenda some months ago, it seems that today, in the context of this discussion, it's premature, because the specification needs to advance some more before it's possible to bring it into a joint working group. There's been some good progress during the year, with a cost mobilize workshop where the idea was said to be interesting. the fact that we've just heard that it's covered by the charter of this interest group and has been endorsed by the RDA Council, and a recent TADWIG session which said that the time to is ripe to advance further. And if you want to follow and contribute to it, you can find the work in a GitHub repository under the general DISCO work, and you can contact me by email if you would like to become involved. And our current expectation is that in the middle of next year, we might propose a task group in TADWIG to more formally take on the work within the overall global community. And then it would be appropriate at that point to see if a RDA working group is needed to work on some specific RDA point or output in support of that work. And so we need to think about what that might be and how we might prepare for that between now and next year, because we need to have something to do in this interest group in between plenary sessions like this one. And here are some ideas which I just throw up for discussion, this slide and the next slide, about how we could exploit and really benefit from the participants in this interest group. We could, for example, gain the involvement of other areas of RDA expertise to provide us with input on specific topics that we need to consider when thinking about open digital and open digital extended specimens. And there are some suggestions of some other interest groups and working groups of RDA which may well be able to contribute. Some specific issues we might want to talk about are things like, well, we know that links between data are better when links point in both directions. So what kind of backlinking strategies could we put in place for digital specimens that would grow the PID graphs and the connections between, not only between different digital specimens, but between digital specimens and data that is derived from them. I listened this morning to a very interesting piece of work that's been done in the biohackathon this week for the herbarium specimens which are in the Meiser Botanic Garden in Belgium. They have spent the week trying to identify DNA sequences from those that have been taken from those specimens where the data has been lodged in GenBank and the European Nucleotide Archive. And they're developing techniques for making those identifications, and they managed to pull out 6,000 sequences, which they think that they can link back to specimens in the herbarium there. But those might only be one-way links to start with. So how can we make those bidirectional? Thinking about how digital specimens are a kind of fair digital object, what are the granularity considerations and the trade-offs in the design that we have to make? How big should a digital specimen object be? How should it be allowed to grow, and when should it split into smaller parts? How can we optimize the content of a digital specimen for efficient processing, efficient unpacking? There's a trade-off between the amount of metadata that you include into a digital specimen versus the amount of time that you spend resolving persistent identifiers and following links to data which tells you, or to metadata which tells you what the data is about and whether it's interesting or not. We have to position digital specimens in this internet of fair data and services, and you've heard Ivan already talk about fair implementation profiles. So what is the fair implementation profile for digital specimen data? And this can be based, for example, on a fair implementation statement that DISCO already has in its data management plan. And what does it mean when digital specimens are machine actionable? Machine actionable is a bit different from machine readable, because digital specimens are examples of fair digital objects. Then what we conclude about machine actionable digital specimens can have wider and more generic influence into other areas of the data fabric, and in other sectors where fair digital objects are to be used throughout the EOSC, for example. So there are some ideas about things we could discuss in this topic, and I think we have some time now to throw the doors open to allow people to give some opinions and suggestions, and see what they think is important for this this interest group to discuss in the coming months. Thank you.
Thanks, Alex, for this interesting talk. You are right that we are planning to have these in between working sessions, in between the plenaries. If you look at our new charter in RDA, you see that also mentioned in the timeline in the charter. What we would like to use these working sessions for is things like Alex suggested here, but also any other things that you are currently working on in any project and that you think would benefit from rapid progress if there is a working session in the wider interest group organized for that. Luckily, we have 4 chairs for this interest group over the different pieces of the world. So we can also run these working sessions in different time zones if that's necessary, so that we can have full participation of all the interested people in the world. Before we start the discussion on the topics that Alex suggested, you can also put your own ideas for other topics in the document with the notes, or you can contact me or Libby or one of the other chairs if you have any ideas for the working session. And I see some questions in the chat, so let's first go to these questions in the chat. There is one from Donat. What do you want to achieve with a digital specimen besides having one? Do you have a specific use case in mind, as a direct use for IPBES or other conservation efforts?
Do you want me to answer that?
Yeah.
Okay. I think the answer to that question is that digital specimens and what is called the data fabric, which is made possible by digital specimens, support many different kinds of use cases. We have many lists of use cases is the answer to that question in various projects, such as the recently finished iStick project. We have collected, I think, some hundreds of different kinds of use cases. We really see digital specimens and also the extended specimen concept as being an enabling technology for new kinds of working practices, which are based upon computerized analysis of data. And by creating these containers of links to, these containers of pointers to all of the different kinds of derived data that has been derived from physical specimens, makes it far easier to, first of all, to place application programming interfaces, APIs, over the top of this data fabric, and second, exploiting those APIs to run many different kinds of new and exciting data science applications. I think if you wanted to think about how this might change working practices, then I think the best kind of example to think about is to think about how the easy availability of gene sequences has changed the understanding of the relationships of different organisms, one with another, through the practice of phylogenetics. If you just take yourself back, 10 or 15 years before phylogenetics became a thing, then I think you will see that the availability of that digital data has really revolutionized the working practice and the scientific understanding. And we think digital specimens have the potential to do the same kind of thing.
Okay. And Donald is saying, but phylogenetics has been the question, not creating sequences.
Well, I think phylogenetics arose because you could create sequences.
Is it possible to speak?
Yes.
Instead of writing? No, I have a very basic question here. Phylogenetics is a science. Do you want to know something about this? Similar to CERN, they have very big science questions, and then you build an apparatus, you build an infrastructure, which is very much defined to help to solve these problems. For me, the digitization per se is sort of something for itself. It has no real goal besides just digitization. And which makes it also very difficult to fund, for example, because in science, okay, we digitize, but if you have a question like you would say, I'm interested to chart life on Earth. My goal is, like in astronomy, to know all the species in the world. Then you would digitize this in a particular way to actually support this very specific project. Because the problem is, you will see is digitization comes at a high cost. So it's relatively cheap to digitize a specimen in a herbarium sheet, but to digitize a very fragile mosquito is very, very expensive. So the question is really, for me, is why do we digitize? What do we want to achieve with this digital specimen?
Who wants to answer that? For me, I could answer, Donald, that first of all, one of the intentions that we have in DISCO, in the DISCO research infrastructure, is that we develop a joint research agenda so that we can prioritize, for instance, what to digitize. And we are building tools like Elvis, where people can apply in groups for digitization on demand, and where these can be prioritized based on the current research needs. But apart from that, digitization on demand is relatively expensive, because you need to do a lot of labor to select these specimens and to individually digitize them, where it is much cheaper to digitize on an industrial scale and just digitize whole collections. And often you want to just digitize because you don't know what you have in the collection. So the digitizing is a way to find out what you actually have in your collections. So at the moment, only about 5% or even less of the collections in total is digitized in any form.
Sorry, Walter, can I jump
Yes.
in, please? Sorry, I raised my hand, but probably you don't see the participants list. Donald, I actually think the answer, you included the answer to your own question in the question itself, to some extent. yeah, I fully agree. I think we all agree in the sense that we've seen in the past a lot of digitization activities, and I'll talk for the European side at least, that in fact they were not purposefully targeting specific scientific needs. They were mostly being done in a context of a, I don't want to say purposeless, but definitely not targeted effort of moving data into the digital realm. And as you say, these are very, very expensive exercises. So I think this is exactly why the need for a better context that is substantiated through things like infrastructures allow you all of that digitization effort to really gain value within existing or future use cases and activities that allow this interconnection of information to happen. So yeah, I agree with what you say, and we shouldn't, and no one should be digitizing without understanding how the data produced from that process will be a part of a wider landscape of connected information. We've done this in the past. A lot of the museums done this in the past. And I think with infrastructures and common understandings like DISCO, but not only, is how you actually can accelerate the science. And a fantastic example that we have in the world is GBIF around this. I mean, see all of the information and the hundreds of publications that are produced based on GBIF mediated data that are the results of a digitization process, at least for collections, in one way. So there is definitely need for better metrics, better targets, and better context that leads to better information for decision making on how and when and which parts of the collections that we have need to digitize.
Yeah, because like we introduce things like MIDS 0, MIDS 1, MIDS 2, and MIDS 3. So like as has been mentioned before, right now there is this Elixir biohackathon, and there are two groups working on specimens and sequences and taxonomic names, and the both have one big problem is that you can digitize, but then you have something on your paper like an accession code, and then it means you have to go out and make sure the accession code is really what you talk about. So it has a lot of elements in digitization to make it really useful data. And each step becomes even more expensive because it needs more time, it needs more people, it cannot automate a lot of that stuff. So that's why I think it's very important that one is very clear why and what we digitize. And these concepts of MIDS, I think it's very important, but I think it should be linked to usages, particular usages.
I see another question in the chat from Ivan. Question for Alex and all. Is it relevant to think about digital populations, communities, or ecosystems? And start, and I think you mean Ivan, a research infrastructure there on that instead of just digital specimen. So we can work on digital twins for ecosystems and maybe work on simulation scenarios on that.
I mean, Dimitris has already answered the question in the chat, and he said yes, and I will also say yes. And Ivan may know about the Ireland Avatar project, which is based around Moorea in French Polynesia, which is led by Neil Davis from Berkeley University. And that is exactly intended to be, or is evolving into being a digital twin of of a Pacific island ecosystem. So yes, there is work already going in there, and I was speaking to Neil earlier in the week, and he is very interested to have further discussions about the role that digital specimens can play in such a digital twin for an island ecosystem. It's perfectly possible to start an interest group on it if there are enough people willing to get together to discuss it and propose it. I'm sure Wouter would say that in fact it could even be set up as a sub-working group of this interest group if there was a sufficient interest to do so.
Yeah, thank you. Yeah, really. And then thinking thinking about Donat's comment, I'm not really aware a lot about specimen digitization, but I'm not sure, for example, the digitization is made in 3-dimensional things, so we can really have an object, I don't know, for example, a fish, who is really reconstructed in this 3D space, so we can use it in an environment. So this is maybe an idea about the fact that if there is a big cost to digitalize specimen, and if we realize in 10 years that we don't digitalize in a manner that we can have 3D object, libraries of 3D objects we can just use in complete, maybe more complete environment like an ecosystem. This can be quite an issue. So just thinking about that, I'm saying that if we are maybe aiming something larger, I don't know, in terms of space, 3D space. So a specimen, a digital specimen is maybe not exactly the same that we exist for now, for example. Don't know.
Okay, there's another question in the chat. The question is, this works well for already published specimens, but what about those that are restricted to specific policies which do not allow this to openly share? Are there any international policies with aid on this matter?
I'm not sure I can answer that question.
What we can answer, I think, Alex, is that we are planning to have digital specimens, not only for specimens specimen data that we can openly share, but also for specimen data that has some restrictions in terms of legal restrictions or political restrictions or other restrictions. So in the DISCO infrastructure, we are taking into account that we also need to share this information with certain groups of researchers that need that. Okay, we have a few minutes left. Maybe it's good if you put on your second last slide, Alex, with the first proposals for a working session. Yes, this one. So my question to the audience is, would you be interested in any of these topics that are proposed here for a next working meeting? Anybody has any thoughts about this?
I'm a co-leader, co-chair of the Sharing Rewards and Credits group, interest group. I think that I could have input for this new interest group if needed.
Can you speak up a little?
It's Romain David. I'm a co-chair of the Sharing Rewards and Credits interest group.
Yeah.
So don't hesitate to ask to me to join if needed.
Okay, thanks for the offer. I think it will be interesting to have a co-session. Any other comments? No. Now what we can do, Alex, is that we send a message to the whole interest group with these topics as a proposal, and then we can see what the interests of the people are. You could maybe have a voting procedure that people can let know their preference.
Yeah, I was just going to suggest we could have some kind of poll to get some kind of count of interest.
Yeah, and I think it would be better to do that with the whole group than with only the participants that are currently here. Okay. And again, if you have any other things that you are currently working on in the project and that you would like to use the interest group for to make some quick progress, please let us know as well. Okay, we are almost at the end of the session. Libby, is there anything else that you would like to mention before we close?
Yeah, nothing else from my end. Thank you to all the speakers for great presentations that really, I think, set the stage for some great conversation in the chat and some Q&A here. I tried to take some notes as folks were talking and presenting, but, and I think most folks now are probably aware of that link already. I'll just drop it in the chat once again. And this session has been recorded. So I think the RDA plenary will be making these available within a day or two. So we'll have that available for rewatching.
Okay, thanks everybody for attending, and see you next time.
Thanks, everybody.
Thank you.
Thank you very much.
Thank you for the organization. Thank you. Bye.
Thank you. Bye-bye.
Take care.